All right, we're in section 4.5 where we are going to prove triangles are congruent by angle side angle and angle angle side. So in previous lessons, we were able to discover that triangles could be congruent by using either one of these theorems or postulates. We looked at side, side, side was one. We could use side, angle, side. We could also use hypotenuse, leg as a way of discovering if triangles were congruent. So um, today we're going to look at the last two um, postulates and theorems that could make triangles congruent, and that's angle side angle and angle angle side. So angle angle side basically means this is you are able either are given or we're able to prove that two angles are congruent. And again, the side that is either proven or given is in between those two congruent sides. So if you notice how the congruence value is between there and there, so um, we can say that by angle side angle that triangle ABC is congruent to triangle DEF. The other one is angle, angle, side. So in this one here, we have two angles that are congruent. We either are given that or we're able to prove that. And the congruent side is not in between those two congruent angle measures. Okay, so that's the big difference between the two. All right, so now we have all of these theorems or postulates at our disposal. We're able to, um, we can utilize any one of those to help us prove that a triangle can be congruent. So we have, again, we have a series of diagrams to look at. We're going to be asked if we can prove it using any one of those. So looking at the first diagram right here, um, I'm just going to attach letters to each vertex here. So let's just call this A, we'll call this B, we'll call this C, we'll call this D, and we'll call this E. So what I was asking you to do first is to establish what is given to you. So looking at what is given to us is we can say that angle A is congruent to angle E. And another thing that's given is angle C is congruent to angle D. All right, the hash marks tell us that those two sets of angles are congruent. All right, that's the only thing that they give us. Now we have to be able to figure out what can we prove. All right, the only thing that I see that we can prove is I can prove that angle ABC is congruent to angle EBD. So right here, I can prove that those angles are congruent because they're vertical angles. Problem is there is no way to prove that any one of those sides or any one of those sets of sides are congruent. And there's no such thing as an angle, angle, angle theorem. So we do not have enough information to prove triangles are congruent. So let's look at the second one here. So again, I'll call this A, we'll call this B, call this C, call this D. Figure out givens. I realize that angle A is congruent to angle D, and I know that uh, angle ABC is congruent to angle DBC. I had to be more specific because they shared a vertex B, and so I had to use three letters to establish that angle. Um, Things I can prove. I can prove that BC is congruent to BC due to the reflexive property. Because I have the reflexive property, I have two angles and a side. That particular side is not in between those two congruent angles. So yes, I can prove triangles are congruent using angle, angle, side. Looking at this next one here, I go A, B, C, D, E, name them. The givens, in this instance, I know that angle C is congruent to angle D, and I also know that BC is congruent to BD. So that's what they gave us. We can prove, I know that this angle here is congruent to this angle here because of vertical angle. So I can say that angle ABC is congruent to angle EBD, vertical angles. So I have two sets of congruent angles. I have one congruent side. That congruent side just so happens to be in between those congruent angles. So yes, I can prove these triangles are congruent using theorem with angle, side, angle. All right, so looking at these two diagrams, now they gave us a congruency statement with a question mark. So now, because they gave us that congruency statement, first thing we have to do is make sure that, of course, the things that are given to us correspond with the correct positioning. So if we look here, you know, angle S is 60 degrees, angle V is 60 degrees. S is the first one, so is V, so that checks out. So looking at the givens, I can say that angle S is congruent to angle V. They're both 60. Other thing is given, we have two right angles. Since we have two right angles, looks like it's under T and under W. T and W are the second letter, so that makes sense. So because there's more than one angle with respect to T and W, I have to say that angle STW is congruent to angle VWT. So those two are congruent. So that's what's given to us. Is there anything that we can prove? Well, this line segment here is shared by both of the triangles. So I can prove that TW is congruent to TW because of the reflexive property. And I have an angle, and a side. So I can say that, yes, I can prove these triangles congruent by using angle, angle, side. Looking at the next diagram, again, they're trying to say is STW congruent to VWT. Again, we have to figure out what is given to us. So we have, looks like angle SWT is congruent to VTW because they both have those hash marks. And we can also say that angle STW is congruent to angle VWT because they both have the 90-degree mark. So we have two angles, and now we have to figure out what can we prove. We can prove that this line segment here is shared, so I could say that TW is congruent to TW because of reflexive property, and so I could say yes, these triangles can be proven congruent using angle side angle. All right, so here we have a diagram of telling us that angle 1 is congruent to angle 4 and CF bisects angle ACE, and they want us to write a proof to show that put it in different colors. They want us to show that CBF, this triangle here, is going to be congruent to CDF. So the red triangle and the blue triangle in this diagram that I drew. All right, so make up proof here. So I got some statements and some reasons. So let's right off the bat, let's write what is given. So I know that angle 1 is congruent to angle 4. I'm just going to put little hash marks there because they told us that. And they're telling us that CF bisects angle ACE. That's given. All right, so if you remember, when we're talking about something that bisects, that means it splits that angle into two equal parts. So something to keep in mind. Okay. All right, so second step, since that's what was given to us, what can I prove? I notice right off the bat that CF is something that is shared between the two respective triangles that we're trying to prove. So I can go right off the bat and say that CF is congruent to CF because of the reflexive property. All right, so I have a side, hoping that I can show that either another side or two more angles are in fact congruent. So I look here and I look at these two angle pairings. They are a linear pair. When they are a linear pair, they are supplementary. So I'm going to say that the measurement of angle 1 plus the measurement of angle 2 will equal 180 degrees. We also know that the measurement of angle 3 plus the measurement of angle 4 is also going to equal 180 degrees by the definition of supplementary angles. from that, I can say that the measurement of angle 1 plus the measurement of angle 2 will equal the measurement of angle 3 plus the measurement of angle 4. Because they're both 180 degrees, I can say that the transitive property allows me to do that. Then I'm going to substitute the whatever angle 4 is with angle 1 because we established that 1 and 4 are congruent. So I can say that the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 3 plus the measurement of angle 1 by simply substitution. All right. Now I can subtract the measurement of angle 1 to both sides. Now I have angle 2 is congruent to angle 3 by subtraction. So now I know that I'll just read. So here, here, now I know that not only these are congruent, but I can say that these two are congruent. So now I got a side, I got an angle. So now the next step here, 7, is I'm going to look at this angle pairing because in the given statement it says that CF bisects angle ACE. Well, by definition, it breaks up into two equal parts. So that means whatever this angle is here, this angle is going to be the same. So I can now say that that angle, we'll call it BCF, is congruent to angle DCF by the definition of angle bisector. So now I have two sets of congruent angles. I have the two sets of congruent sides because of the reflexive property. So now I can say that triangle CBF is congruent to triangle CDF because of angle, angle, side. Because angle, angle, side, angle, angle, side. All right. So here in this proof, they're telling you that CF bisects A C A C E and B F D. Let's do it. So CF is right here. So it's A C E and B F D. Okay, so with that given statement, they want you to find that CBF, this triangle here, is congruent to CDF, which is right here. Okay, so using similar ideas, since they didn't give us everything the same, we have to kind of use this proof differently in order to write these. So again, we have statement and reason. So here they are telling us that CF bisects angle ACE and angle BFD. D. So that's given. All right. So now we kind of have to utilize those two bisected angles to help us solve it. So I can now say that angle BCF is congruent to angle DCF due to the definition of angle bisector. And so that would make that this angle and this angle are the same. And now that they added BFD to this, actually I can tag that angle BFC is also congruent to angle DFC by the same definition. So I just keep that in the same statement. So I can say that this is congruent and this is congruent. So I now have two sets of congruent angles in this case here, and then I can go about and use the reflexive property like I did in the previous one and say that CF is congruent to CF due to reflexive. And now I have two sets of congruent angles. I have one set of congruent sides. So I can now write that triangle CBF is congruent to triangle CDF because of angle side angle. And that is being able to prove triangles are congruent by ASA or and AAS. Hope this helps. Till next time.